Unit 7, here we go. Trigonometry. You're going to get hit with trig now. So Algebra 2 is not messing around. We're going to introduce you to trig. So trigonometry is really the study of right triangles. You guys back in geometry class, you remember you had 45, 45, 90s, 30, 60, 90s. A squared plus b squared equals c squared. Pythagorean theorem only works for 90-degree triangles. You see the theme? And so trigonometry, the stuff we're going to learn at first, will also only work for 90-degree triangles. So when you had geometry class, there was special right triangles, 30, 60, 90s, and 45, 45, 90s. I just said this, but families also. Trigonometry kind of takes care of the other 99.99% of the real triangles out in the real world. If you're actually building something, anything, you're not going to have all these perfect little 30, 60, 90s or 45, 45, 90s. Not everything's going to work out to be a family. So trigonometry is kind of the reality of right triangles. Special right triangles is really just this perfect little math world. So enough. Let's get into it. So I apologize for this red. I can see it doesn't show up too well, so I'll stick with the darker marker from now on. But let's just start with the basic idea. We got ourselves a right triangle with that little symbol. A right triangle, and you're going to see a million of them, have two legs and one hypotenuse. Remember, this long side is the hypotenuse. Now, some of you are like, yeah, that's the side opposite the 90. You're right. It's the longest leg of a right triangle. Now, in a squared plus b squared equals c squared, the hypotenuse has to be the letter C. Has to be. Now, I could put this as A and that as B, and another student might make this B and that's A, and that's okay. But the letter C has to be, the one by itself has to be the hypotenuse. So there's a little warm-up for you. All right, and let's go ahead and put some values in there. Let's say this is 2, and let's say this is 6, and you have to find B. So you go a squared plus b squared equals c squared. That's 4 plus b squared equals 36. Subtract 4, subtract 4, so I get b squared equals 32. Bada boom, bada bing. We don't have to do the right thing because this is a length. But that would break down to 16 and 2, which is 4 square root of 2. All right, Pythagorean theorem. Go math. I'm going to finish this up. Families, which are also called by your geometry teachers your Pythagorean triples, same thing. We got a 3, 4, do you remember? 5. We got a 5, 12, 13. We got an 8, 15, 17. We got a 7, 24, 25. Now there's many uses for these families, but it's really not our subject. We're not studying families right now. I'm just throwing this into your kind of rub those brain cells together, see if you guys remember those. So what's the advantage of knowing these? Well, let's say you have a problem like this. I want that to be a 7 and 25 and x. You're like, well, I could go a squared plus b squared equals c squared. Yeah, that'll get the job done. But if you know your families, 7, 24, 25, you're like, I don't have to waste my time doing that. So remember, timed tests, these little tricks are valuable. Another trick, so let's say this is 50, and this is 48, and this is x. And some student might go, okay, I'm going to go x squared plus 48 squared equals 50 squared and just crunch it all out. Oh, you'll definitely get the answer eventually, but those numbers are huge, and if you're on a timed test, watch this trick. What goes into both 48 and 50? Well, 2 does. So I divide that by 2, I get 25. If I divide that by 2, I get 24. Well, then I go, aha, this has to be 7. But these were not the original dimensions. I divided by 2 to get these dimensions. So the real dimension is 50, the real dimension is 48, so the real dimension on that has to be 14. I never really did much math at all, and I got to the length of that side quite quickly. Let me pause this. All right, the old infamous SOHCAHTOA. You got to have this memorized. So there's a little phrase for you. So katoa. It's like PEMDAS. Please excuse my dear Aunt Sally. It's one of those staples in math that you'll never forget. Once you use it, work with it. What is this supposed to be? Well, first of all, I want you to know that this first letter S stands for the word sine. And then this stands for cosine. And then this stands for the word tangent. I'm going to grab my calculator a minute. And I know this can't zoom in very well, but if you have a calculator like this, you're going to see buttons that have, watch this, they just chop off the E, so that's still sine. Look for that button. Cosine, C-O-S, tangent. So they abbreviate these things just using the first three letters just to make life simpler, okay? Now, what is this O-H-A-H-O-A? So this word O stands for opposite. This stands for hypotenuse. That tells us we're dealing with 90-degree triangles. So this is adjacent, and this is hypotenuse. And this is opposite, and this is adjacent. So we better know what in the world these even mean. So what I'm going to do is I'm going to draw a right triangle. There it is. Now I'm going to put this little symbol in there. That's theta. It's a Greek symbol. And trigonometry starts using these sort of Greek symbols to represent an angle. So this could be 27 degrees. It could be 65 degrees. It's just a symbol that represents an angle. And then they also introduced to us symbols like this, alpha. Now, just so you know, I'm going to pick this angle to be what's called my reference angle. I'm going to concentrate on it. So, and now I'm going to concentrate on this word opposite. Well, opposite just means across. So if I go across, this would be, it has two names. It's the side opposite, I'm going to abbreviate, alpha. Well, then if I use the same logic here and I go straight across, this side has a name, side opposite theta. All right. Well, let's take the low-hanging fruit. What is the name of this side? Well, that has to be the hypotenuse. How do you know that? Two reasons. It's the longest leg in your right triangle, and it's the side opposite your 90. That's just an always. Now, there's something else, though. Notice I have not used the word adjacent yet. Adjacent. Now, I don't want to make this difficult. There's a real easy way of thinking of it. If this is my reference angle, theta, this is my opposite. And if this is my hypotenuse, then the third side that I haven't talked about, Sam, this is opposite, this is hypotenuse. This has to be also the side adjacent to theta. Just means next to. So if this is my theta, this angle, right, this side is next to that angle. Now you might say, well, so is that, but that's already been taken. That's been given the name hypotenuse. So now look at this. If I change my reference point, I think, or my reference angle, that's alpha. This side is opposite alpha. This side is my hypotenuse, meaning this side is also the side, here it comes, adjacent to alpha. So it depends on what your reference angle is. Now, having said that, if you're a little bit confused, now what I'm going to do is help you understand what this is all about. So, sine of theta, cosine of theta, tangent of theta. Now let me give you an actual problem. So let's put the theta right there. Let's take one of our triples, a 3, 4, 5, one of the simplest triples, and let's try to make sense of this. Well, first of all, this little symbol is telling me, hey guys, concentrate on that. Like, okay, I'll concentrate on it. If that's my reference angle, that means this is my opposite side, this is my hypotenuse, and then by process of just sheer elimination, this has to be my adjacent side. Well, it's asking me to find sine of theta. Well, that's what this memory tool is all about. That means it's going to be the opposite side all over the hypotenuse. Now notice, so that's the memory tool right there. So let's go ahead and figure it out. What's the opposite side of theta? Well, that's the 3. What's the hypotenuse? Well, that's the 5. As long as this is reduced, you're good. So we're good. How about this? Cosine of theta. Well, by definition, it's the adjacent over the hypotenuse. Where did I get that? Ka. See that? Ka. So that's our memory tool. So what's the adjacent side? Well, we've got it labeled. It's a 4. What's the hypotenuse? That's still a 5. How do we find the tangent? Well, tangent is TOA. Opposite over adjacent. So opposite over adjacent. Well, what's the opposite side? 3. What's the adjacent side? 4. I'm done. But there's always more in math, isn't there? And here we go. Let's see how much time I have. Plenty. So, just so you know, there's a reciprocal function of sine, and it's called cosecant. Now, that is the reciprocal of sine. So, first of all, notice abbreviate to 3 letters, abbreviate to 3 letters, abbreviate to 3 letters. If I abbreviate this to 3 letters, I got a problem. It's going to match cosine, and that'd be too confusing. So rather than taking COS, they make it CSC. And that's just what math did. Okay? I'll make that darker. It doesn't show up very well in red. So I've already told you it's the reciprocal, so we're just going to flip that, 5/3. So the math is easy. You just flip sine. You just have to memorize that cosecant is the reciprocal of sine. All right. What's the reciprocal of cosine? Well, that thing is called secant. Now, if I chop off the first 3 letters, I'm going to get secant. And I didn't use that yet, so that's fine. And if I know that secant is the reciprocal of cosine, which I do, I just flip that. Because that's what secant is. It's the reciprocal of cosine. We'll go to tangent. The reciprocal of tangent is cotangent. And if I chop off the first 3 letters, we're good. So cotangent, we just flip tangent, that's 4/3. And there you have the 6 trig functions. There are always 6. There's sine, cosine, tangent, and then their reciprocals. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. I know that's a lot, but you got to have that going on, okay? All right, next example is kind of heavy. So they're going to come at you a little different. Now notice the previous example, I gave you a triangle and had you find all 6 trig functions. This one comes at you a little different. You have to kind of get out your magnifying glass and see what they're telling you. They're saying if tangent is 15/8, which I will just put right here, which by the way, I don't need to know anything else except that this is the reciprocal. So now we really only need to find the other 4. But it says find the other 5 trig functions. So I'm like, well, okay, how? I don't have a triangle. Exactly. We have to think to ourselves, what is tangent? Well, so, ka, toa is telling us what tangent is. We don't care about those because this is a tangent problem. So they're telling us tangent is 15/8. Well, if tangent is opposite over adjacent, that's their way of telling you that 15 is the side opposite the angle and that 8 is the adjacent side. So if I try to get a picture and I try to do it with some accuracy, now I'm going to draw a little random one. And I'm like, okay, now your drawing might not be to scale.